Hello everyone. In this video we are going to look at how to find the zeros of a polynomial function and then later on write these polynomials as a product of linear factors. Okay, so let's look at this first simple example. We are given a quadratic polynomial which is fx equals x squared plus 10x plus 23. And we would like to write this polynomial as a product of linear factors. Now, when we look at this problem, guys, notice that it's not easy to factor it out. So we have learned a lot of, techniques to find a solution to this quadratic function. And one of the easiest and the most simplest one is called the quadratic formula. So this, guys, is the quadratic formula. So what we're going to do is we are going to apply the quadratic formula to get the zeros of the function. Because remember, when I say the word zeros of the function, that means I'm asking fx equals 0. What would be the x's value which will satisfy this equation? So in order to do that, what we're looking at solution of this quadratic function, we are going to apply the quadratic formula. Now, let's look at what is given to us. A over here is 1, B, which is the coefficient multiplied to the variable x, is 10, and C is 23. What we're going to do, we're going to write this one as, so this one, remember the function is what? Now it's x squared plus 10x plus 23 equals 0. Okay, now just plug now. Remember the formula is minus b plus minus square root b squared minus 4ac over 2a. So b here is 10. So when plug in the values, you get negative 10 plus minus square root 10 squared minus 4 times 1 times 23. Notice how I am so careful with my parentheses, because there's a possibility negatives might pop up later on. So I want to make sure that I keep on putting my parentheses, getting used to the parentheses here. Okay, and then we divide this by 2 times 1. And then it's simply plugging in your calculators and you do the math. So inside the square root is 100 minus 92, which gives us an 8, and the rest, all of them follow. Okay, now let's look at this equation. X equals minus 10 plus minus square root 8 over 2. You see, I said square root 8 is 2 root 2. So let's look at a little more deeper into this radical root. Now, what is square root of 8? It is 4 times 2. Now, we know we can write this radical root applying the formulas of that as square root 4 times square root 2, which is the square root 4. We all are so easy. We know it's 2. So the square root 2 now is written as 2 square root 2. That's what we plug it in over here. And now look what is common between each of these terms. 10, 2 root 2, and 2 is a 2. Now I need to see how it came about. So what we're going to do is we're going to write this as, let's look at the 2 common out on the top. So 2 is common, and you get negative 5 plus minus square root 2. Remember, you're applying the distributive properties, divided by 2. So this 2 and this 2 cancel out. What are we left with? Minus 5 plus minus square root 2. So we have been able to find the zeros of the polynomial, and we would like to write this polynomial as a product of linear factors. How do we do that? Now remember, once you know the zeros, so there are 2 zeros from here. Remember, what is it? X equals minus 5 plus square root 2 and minus 5 minus square root 2. Now to write this polynomial as a product, so what I'm going to see here is this our polynomial is what? It is x squared plus 10x plus 23. This is written as x minus. Okay, I'm going to just, so x minus of minus 5 plus root 2. So it's going to be x minus of minus 5 plus square root 2, then times. Okay, I'm getting off the space, guys, so I'm just going to move a little bit because we need this one now, okay? So it's x minus of minus 5 minus square root 2. So when I open this up, and I'm going to go on the top here, so I'm going to go here, guys, to write the answer. it's x minus, now minus goes inside, okay? It's plus 5 minus square root 2 times x plus 5 plus square root 2. So this polynomial, x squared plus, let me just write it more nicely. Okay, plus 10x. So x squared plus 10x plus 23 is written as, in terms of linear factors, x plus 5 minus square root 2, x plus 5 plus square root 2. Okay, now let's go ahead and look at another example. Now we would like to find the zeros of this function gy, y to the power 4 minus 625, and write this polynomial finally as a product of linear factors. Okay, now I have already kind of done the work over here for you, the product as a product of linear factors. What I'm going to do is, guys, I'm actually going to go down and find out how all this was brought about. Okay, so to find the zeros, we're going to go down first. What do you say? We put gy to be 0. Okay, that means y to the power 4 minus 625 is 0. Now let's focus more on this. Now, if you remember the a squared minus b squared, I'm going to write this over here. Remember this a squared difference of squares is what? A minus b, a plus, okay guys, let's, need more space here. I'm going to write it over here. Okay, we are doing a squared minus b squared equals a minus b, a plus b. Okay, so what do we have? Y to the 4 minus 625. So I can write this expression as it is written over here, but I'm going to show you more detail here. So let's look at this expression. So it's y squared square, because y squared square is what? Y4, minus 625 is what? 25 square. So we have a square minus b square. What is my a? So if you notice here, if I match up with the formula, my a is y square and my b is 25. Okay, now we have a to be y squared, b to be 25. I just plug in the terms here. So this expression is going to now become what? Y squared plus 25 or minus 25, doesn't matter. We can write any one first, and y squared minus 25. Okay, now this one is simple because 25 is what? 5 square. So we can write this one, y squared minus 25, as this expression. Okay, let me write it down over here. So we have y squared minus 25, which is y squared minus 5 squared, which is y minus 5 and y plus 5. Okay, so this guys goes over here. Let's look at this one, y plus 5i and y minus 5i. Remember, we have to find the zeros. So we're basically putting this to be 0. So what we're saying is, we are looking at, so when you look at this expression, this, and I have to put this to be equal to 0. So when I put this to be 0, what does that tell me? It says y squared plus 25 to be 0 and y squared minus 25 to be 0. When I put y squared minus 25 to be 0, what do I get? Now, there are many ways I'm showing you guys. Once, if I apply the formula, I can do that. Or if I do not remember, I can use this approach and say, hey, this means y squared is 25. That means y is plus minus 5. So we can go by this route. Okay. So we can go by this route to get this expression, the one which is in green, guys. Similarly, or I can apply the formula. We can go either way, but not to find y squared plus 25. Either if I can see that this is going to use my complex numbers, but if I don't remember, so what do? I look at this expression and I say, okay, let me apply the y squared plus 25 equal to 0 and get me values. And then I can go back and plug it in over here. Okay, so y squared plus 25 is 0 or y squared is minus 25. And we practiced in the previous video session 2, plus minus square root minus 25. We know for the negative inside, the trick is take the I and plus minus 25, which is plus minus I5. Now, we have y to be plus minus I5. And how do we write it? This is how we write it down. Y plus 5i times y minus 5i. So, we have got all the zeros. Y plus 5, y minus 5, y plus 5i, y minus 5i. So to find the zeros, we got 5 minus 5, 5i minus 5. Do you see that over here? So these are the zeros. So once I have the 0, y equals plus minus 5, y equals plus minus 5i. I just go ahead and substitute into my function g of y. Plus means y, so plus 5, y minus 5. Y minus 5, that means y minus of minus 5. Okay, let me write it down over here. Okay, so if my factors are, let's just say that again here, guys. Okay, I'm going to use the red here. So what are the zeros? So according to me, the zeros are y equals plus minus 5 and plus minus 5i. Now to write this polynomial, that means basically this. I'm talking about the polynomial of linear factors. That means I will write this as gy equals, remember variable is y. It does not matter y, t, x. What do you think? It's a variable, guys. So it will be y positive 5, y minus 5, y minus of minus 5, y minus of 5i, and y minus of minus 5i. So when you open this y minus 5, we get this. Y minus of minus 5, we get y plus 5. Y, okay, I can show that here. So y minus 5 is this. Y minus of minus 5 is basically y plus 5 is this. Y minus of 5i is this. And y minus of minus 5i is y plus 5i. So basically, we have been able to write down all the linear factors. Okay, notice when we were doing this, we were actually getting complex solutions, which are basically called complex zeros. So there's a very, very important property. And that is that if you have a complex solution, they always occur in pairs, and we call them conjugate pairs. What simply it means is, this is what I'm talking about, if say x equals to 3i is a solution to a polynomial, okay? This complex conjugate says is, if it is a solution, then automatically or by default, or we can say by default, x equals minus 3i is also a solution. Minus 3i, guys, remember, is the conjugate of plus 3i. Is a solution to the polynomial. That's what it means, that if you have a complex solution, its conjugate will automatically be a solution. So let's read this one. It says, if f is a polynomial function which has real coefficients, yes, very important, real coefficients, then if a plus bi, when b is non-zero, is a zero of the function, then the conjugate a minus bi is also a zero. So now let's focus, what is it? What do you mean by real coefficients? That example is, let's look at this classic example, fx equals x squared plus 1. Now x squared plus 1, automatically we know minus I and positive I will only be a solution. But if I have a function which is like x minus I, oh no. This one does not apply, okay? So this idea about complex zeros only happens if my function is having real coefficients. Keep that in mind. Okay, now what we're going to practice is we're going to actually write down a polynomial function. We will be given the zeros. We would like to know what is that polynomial which corresponds to that. So let's look at this first example. It says find a third degree polynomial function with real coefficients which has 6 and I as zeros. Okay, we say let the polynomial function be, so let's say assume the polynomial function is fx. Okay, now let's look at this. It says it has it's a third degree polynomial. Remember, if it is a third degree polynomial, that means it will have 3 solutions. Very important. Now, as I is a 0, I is a complex number, then by default, which we just learned, minus I is also a solution. And we also talked about the linearization theorem. It says if we have a polynomial function, then according to the linearization theorem, the polynomial can be written in this form. Fx is a, x minus the first 0, x minus the second 0, that is I, and by default minus I is also a 0, so x minus of minus I. So fx is a times x minus 6, x minus I, x of minus is plus I. Now, we will assume and make our life simpler that a is 1, okay, because we have to now do simple multiplication of these binomials. Okay, so this is a binomial. Remember 2 terms. This is a binomial, which is 2 terms. This is a binomial. So what I've done is I've literally done all these steps for you guys, and I will just go over with them with you. And you'll be able to see a third degree polynomial. Remember this one? The previous problem says that f has zeros, 6, and I. So when it is an I, automatically minus I also is a solution. And then by the linearization theorem, we wrote this as x minus 6, x minus I, x plus I, minus of minus I. Now I'm going to do, I can actually do multiplication of these two first or these two. What I tend to do is, to make my life simple, if I have two expressions within complex number, I actually try to multiply them and try to get rid of the i's if I can. Okay, so let's look at this one. X minus I and x plus I. So multiply x squared and then plus ix minus ix minus I squared. Clearly you see ix and minus ix cancel out each other. Awesome. Now, what are we left with? X squared minus I squared. Now remember, the complex thing I squared is minus 1. And this minus is outside. It's not inside. There's no parenthesis. So this is x squared minus of minus 1. And then we do this one, x squared plus 1. In the meantime, x minus 6 is nicely, coolly falling it down. Here is the final thing. We multiply these two expressions. We get x with an x squared, x cubed, x plus x, minus 6x squared, minus 6. And here we have a polynomial, a third degree polynomial. So we have been able to find out a third degree polynomial with real coefficients that has 0, 6, I minus I. Okay, notice in our real coefficients that when we have these zeros, the final answer, because that complex conjugate pairs always should work, my function should have my function in the end, the polynomial, should only have real coefficients. If I end up getting an I, that's a short way that something is wrong here in your computation. So make sure that when you get your final answer, there is no I involved. Okay, let's move forward and do another example. Here we're going to find a fourth degree polynomial with real coefficients, which has 3, minus 1, and 2i as zeros. So automatically if 2i is 0, minus 2i is also a 0. According to the linearization theorem, how can we write the polynomial with real coefficients? A times x minus 3, this is these 1, 0, x minus of minus 1, because minus 1 is a 0, and 2i, x minus 2i, and times x minus of minus 2i. That means this. Okay, so just doing a little simple algebra here, a times x minus 3, x plus 1, x minus 2i, x plus 2i. Notice, to make our life simpler at this point, we say, oh yeah, a is 1, okay? They say, hey, a is 1, don't want to worry about all of that. Now what we have to do is, We just have to multiply these 4 polynomials. Okay, let's do that in the next slide. I have basically done all the little nitty-gritties over here. I'm just going to go over a little bit with you and show you why I picked up this way. Okay, so when we have 4 different polynomials, I'm going to group them 2 at a time. So I'm going to group these 2 at a time, and I'm going to group the complex numbers, the polynomials with complex numbers together. So when I do this one, let's go with the blue one first, and I'll do the red one later. So x minus 2i, x plus 2i. You open this up, x squared minus 2ix plus 2ix minus 4i squared. Because minus 2 with a positive 2i will give me minus 4i squared. Now clearly 2ix and plus 2ix and a negative 1, they cancel out each other. What you're left with, minus 4. Now remember, I square, exactly remember, is minus 1, okay? So then that means x squared minus 4 times minus 1. We get x squared plus 4. Now, this one is very simple. You guys should be able to see it. X squared, you multiply these 2 polynomials, you get x squared minus 3x plus 3x, x minus 3, gather the like terms, you get x squared minus 2x minus 3. Now, we got this expression. Now here what I'm going to do is, it's a trinomial. Remember, it's a polynomial multiplied to a polynomial. And there's no way you can do foiling, okay? So what you're going to do is this. We are going to basically keep one of the, polynomials fixed and distribute the other. So what I'm doing is I'm keeping my x squared plus 4 fixed. I'm going to use the green here. So this is the one, guys, I'm fixing. And I'm basically distributing this polynomial x squared minus 2x minus 3 over here. So x squared times x squared plus 4 minus 2 times x squared plus 4 minus 3 times x squared plus 4. And after that, it's simple because there's only one term in the front and a polynomial inside the parentheses. We just go ahead and distribute. So in the first one, we distribute x squared. We get x4 plus 4x squared. In the second one, we're distributing negative 2x. We get negative 2x cubed and negative 8x. In the final one, we are going to distribute negative 3 inside x squared plus 4. We're going to get negative 3x squared, negative 12. And then we just gather the like terms. So that there are only 2 like terms, only the x squares. The rest are on their own. So we get the final answer to be x4 minus 2x cubed plus x squared minus 8x minus 12. Okay, till now we were doing nice little zeros with no radicals. Let's take an example where we have a radical. And we also have to find a. A little tough, but guys, we can do it. Okay, here's the problem. It says find a polynomial function with real coefficients, which has a 4th degree. And these are the zeros. 1, minus 4, and square root 3i. I is not inside the square root, guys. So if square root 3i is a 0, then minus square root 3i is also a 0. And then we are given that this polynomial, when x is 0, the function value is 6. Oh, got to keep that in mind. Okay. So the first thing we do is we know a polynomial, 4th degree. That means 4 factors will be there. And then we also given f of 0 equals 6. So we're going to proceed very, very slowly and take our time. Okay. So the first thing, according to the linearization theorem, the polynomial can be written as a times x minus 1. That's corresponding to this one. X minus of minus 4 corresponding to the 0 minus 4. Then x minus square root 3i, it is corresponding to square root 3i. Then x minus of minus square root 3i. Remember, if you have one of the solutions, which is a complex, the other conjugate pair automatically becomes a solution. So it's x minus of minus square root 3i. Okay, now just go and do a little simplest of algebra. Minus with the minus becomes positive. So we have x minus 1, x plus 4, x minus square root 3i. Here again a minus with the minus becomes positive, x plus square root 3i. Now, till now, if you notice in previous, I would say, hey, let A be 1. But now we are actually given this condition that f of 0 is 6. So what we're going to do is we're going to use this to find A. The next slide actually shows you the whole process. Let's talk about that. Okay, so first we have to find the value for A by putting in equation 1. Now this is the equation 1, guys. You see over here? This is the equation 1 we are talking about. Okay, f of 0 to be 6. Okay, now where you have x, put 0. So we had this expression x minus 1, x plus 4. So what I'm going to do is I'm going to put x to be 0, 0, 0, 0. And then f of x, that means remember this is f of 0 is 6. Now this we don't worry. We are going to look at this part. So 0 minus 1, 0 plus 4, 0 minus square root 3i, 0 plus square root 3i. What do we get? 1, 4. Now notice I'm very, very careful with my parentheses. I'm not letting it go, okay, because I have a minus here. So when I do the multiplication, 1 times 4 is 4, minus with the minus in the front because there's only one minus. Now square root 3 with the square root 3, the square root vanishes. We get 3, I with an I square. So you have minus 4a 3i squared. Remember I square is minus 1. So minus 4 times a times 3 times minus 1, I get 12a. So 6 equals 12a. So here, now we know what value of a when I multiply to 12 will give me 6 is 0.5. Or we can divide this whole equation by 12. I get 0.5 equals a. So we actually have found our a. Now, we're going to use this to write down the polynomial. Okay, let's go back. I know it's very daunting, guys. What I've done is I've explained every step for you. Okay, so when you're practicing and your answers are not matching with my final answer, then go back and look at exactly where did you mess it up. Okay, let's first look at this one. So fx is a times this whole expression, which was picked up from slide number 17. A is 0.5, which came from slide number 18, right before this one. And now what I'm going to do is I'm going to multiply these two expressions, x minus 1 and x plus 4. When I do this one, I get x squared plus 3x minus 4. This is easy, guys. You all know it. Now let's look at this one. When I have x minus square root 3i and x plus square root 3i, I'm going to group these two at a time. This is, I've shown you all the little steps, it becomes x plus 3. So go over the steps, guys. My recommendation, please do it yourselves first. Go by slow steps and then say, oh, I'm not getting it. Go back and check. Very important. Go back and check. By this time, you should be able to multiply two polynomials. And take it slowly. Okay, coming back here now. I have this expression and this. So what I'm doing is, once again, I am going to fix one of the polynomials, which is x squared plus 3, and distribute the polynomial in the front. Now, guys, I'm taking this route. Somebody says, oh, no, I want to fix this one, x squared plus 3x minus 4, and I want to distribute this one. Go ahead. It doesn't matter which one you are fixing and which one you're distributing. In the end, the answer will be the same. Okay, so this is my procedure. So I do this one. So when I do the math, then now once I have distributed, I'm going to distribute individually x squared in this expression. 3x times x squared plus 1, I'm going to distribute 3x. And in minus 4 times x squared plus 3, I'm going to distribute negative 4. So go ahead and do this math. And then you get this expression x4 plus 3x cubed, and then adding like terms and stuff like that, minus x squared plus 9x minus 12. Now to get the final answer, I am going to distribute 0.5. Remember, till now 0.5 was nicely following down all the steps, doing nothing. The final one is where 0.5 plays a major role. So you multiply 0.5 to every term here, and this is what you get. So this is the polynomial we're looking at. It's 0.5x4 plus 1.5x cubed minus 0.5x squared plus 4.5x minus 6. Thank you, guys.